Today we are going to look at section 5.5, adding and subtracting rational functions. Just like we've been doing, we want to combine these fractions, but this time using adding and subtracting instead of multiplying and dividing. To add or subtract any fractions, we have to get common denominators first. And that's the big difference between this and the previous section, is that we can't just start in with the addition and subtraction until we get common denominators. To get common denominators, we'll want to factor first if you can. That lets you see what's in each denominator so that we're not multiplying by something more than what we need. Once we factor each denominator, we can multiply the top and bottom of each fraction by what it's missing. Like in this first example, after we factor 2x minus 2, we get that down to 2 times x minus 1. When we x factor the bottom of the second one, we get x minus 1 times x minus 3. Looking at these two denominators, they both already contain an x minus 1, so we don't need to multiply the other one by that, so it saves us a little bit of work. This second fraction is missing a 2 out in front, so we need to multiply the top and bottom both by 2. First fraction needed an x minus 3 to match, so we multiply the top and bottom by x minus 3. When you do this, you do want to multiply the tops together because we'll be combining those. You do not need to multiply the bottoms together because we'll be keeping our common denominator the same. So when we multiply these two tops, we need to FOIL. We get x squared minus x minus 6. Once again, we do not need to multiply the bottom. In the second one, just distribute, you get negative 4x minus 2. Once you have common denominators, you can go ahead and add or subtract the tops, depending on what's in between. And then we keep our common denominator the same. As always, you want to simplify your answer if possible. So looking at a few examples. First one, anytime something's not a fraction in these problems, I always want to make it into a fraction. So I would make 4 into a fraction by putting it over 1. Looking at the denominators, there's nothing to factor, so I just need to get them to match. The first one's a minus 2, so I need to make this second one a minus 2, so that's what we'll multiply by. Whatever we do to the bottom, we have to do the exact same thing to the top, so we multiply both the top and bottom by a minus 2. We didn't do anything to the first fraction, so it's going to stay as 3a over a minus 2. Second fraction, we want to multiply the tops together, so we get 4 times a, which is 4a. 4 times the negative 2 when we distribute gives us minus 8. And then our bottom is just a minus 2. Now that our denominators match, we can go ahead and subtract the tops. We have 3a minus 4a, which is negative a. And then be careful, you have 0 in the first fraction minus a negative 8, which becomes a plus 8. Be careful, make sure you subtract everything in the second fraction when it's subtraction. We keep our common denominator of a minus 2. That doesn't change, so it just stays as a minus 2. We want to see if we can simplify. There's nothing here that can cancel. Can't cancel the a's because of the pluses and minuses after them. Can't cancel the 8 and 2 for the same reason. Remember, you have to have the same factor on the top and bottom to cancel. In our next example, looking at the denominators, they are not the same to start. And I can factor the second one, so that's the first thing I would want to do. I would want to rewrite this second fraction as v over 3 times v minus 3, factoring out that greatest common factor of 3 from the bottom. The reason I want to do that, I can now see that they both have a v minus 3 already, so the only thing I need to do to get a common denominator is multiply this first fraction by 3. Whatever I do to the bottom, I also have to do the top. Combining things in that first fraction gives me 15v plus 30. Once again, we do not need to multiply the bottoms because we're not going to actually be combining them into anything. Second fraction stayed the same. And now that we have common denominators, we can go ahead and subtract the top. So we have 15v minus 1v, which is 14v. Nothing to combine with the 30, so it stays as plus 30. And then we keep our common denominator, 3 times v minus 3. Again, we always want to check to see, can we simplify? But in this case, there's nothing that can simplify there. In our third fraction, our third example, there's nothing to factor with these two, and they're not the same. So unfortunately, we've got to multiply both of these by the other one. So we multiply the first one by x plus 2. And we multiply the second one by x minus 4. You can't cancel anything simplifying wise until we have this down into one fraction. So we need to go ahead and combine these tops. So the top of the first fraction when we distribute gives us x squared plus 2x. Once again, we don't need to multiply the bottoms. Let's leave it as x plus 2 times x minus 4. When I distribute the second tops, I get 3x minus 12. Over our common denominator, x plus 2, x minus 4. Now that we have common denominators, we can go ahead and subtract the tops. X squared, there's nothing like it, so when I subtract, it stays as x squared. I have 2x minus 3x, which is minus 1x. And then nothing minus negative 12 becomes plus 12. Common denominators stay the same. Now that we've subtracted and combined them into one fraction, we do want to see if we can simplify this at all. So this goes back to our last few sections. We want to factor anything that we can and then cancel anything that we can. We can x factor the top. The top x factors down into x minus 4 times x plus 3. And now that we have a common factor of x minus 4 in the top and bottom, in a single fraction, we can cancel it. Once again, you cannot cancel in earlier steps because of the plus or minus in between those two fractions. When we cancel the x minus 4s, we're left with x plus 3 on the top, x plus 2 on the bottom. It's very tempting to cancel those x's. Once again, those are not factors. It's x plus in each case, so it's not x times. So that is your final answer. In our last example, once again, the denominators don't match. And since there's pluses or minuses in them, we need to factor them first. Factoring the first one, give me x plus 4 times x minus 3. Factoring the second one, give me x minus 3 times x plus 1. Now that we factored them, I can see that there's an x minus 3 already in both of those. So I just need to multiply by what's missing. So from the first one, I would multiply the top and bottom by x plus 1. And I would multiply the second one, top and bottom, both by x plus 4. In the top of the first one, we've got a FOIL, so we'd get x squared and then minus 2x plus 1x would combine to give me a minus x in the middle, and then minus 2 for our last term. Common denominators, we do not need to multiply those together. Just leave it as x plus 1, x plus 4, and x minus 3. Second fraction, just distribute. A little bit easier. That's x squared plus 4x. In the bottom had an x plus 1 times x plus 4 times x minus 3. Denominators match, so we can go ahead and add the numerators. X squared plus another x squared would give me 2x squared. Negative x plus 4x is plus 3x. And then negative 2 plus nothing is just minus 2. Common denominator stays the same. Now that we have one fraction, we would want to see if that simplifies at all. So we would need to x factor the top. I believe it x factors down into 2x minus 1 times x plus 2. Double checking that, I'd have 2x squared. I would get a positive 4x and a negative 1x, giving me a positive 3x in the middle, and then a negative 2. There are no common factors in the top and bottom, so nothing actually factors. I would accept either the bottom or the next to last one as a final answer. The bottom one just shows me that you did check to see whether you can cancel anything or not. Sometimes you can, sometimes you can't. These problems are long. They do take a little bit of time, but they're all steps that we have done before. It's just kind of putting them all together. As always, you have practice problems that you can check, and please feel free to reach out with questions through email or through Flipgrid, whatever is easier. Ask questions, ask questions, ask questions.